Hi everyone. So this afternoon I'd like to talk with you all about the story of the current state of smart ticketing in the United Kingdom. But before I do that, I want to give a brief introduction about myself. So I currently work as a software engineer for Skyscanner over in Glasgow, and I'm working on payment systems over there. Over the summer, I graduated from Abertay in Ethical Hacking. I probably have a really funny accent. I moved to Scotland 40 years ago. Prior to that, lived in the Dominican Republic and was born in California before then. I'm really keen on the interaction between security and user experience. I'm also really interested in embedded devices, payment technologies, and I'm really into public transit as well. So this talk is essentially an overview of a lot of the research that I completed as part of my honours dissertation, as well as some later work that I've done since leaving university. So if you often visit major cities, you probably have a drawer full of transit cards. So here are a handful of transit cards that I have at home from a couple of cities across North America and Europe. Now, in the late 90s, the Department for Transport in the United Kingdom formed this organization called ITSO with the idea of trying to develop an interoperable smart card scheme in the United Kingdom. So essentially, back in the 90s, they foresaw that this was going to be a problem. They figured, okay, different cities are going to launch different smart card schemes. They're not going to be compatible with each other. And it's going to end up with people having to carry all sorts of different smart cards around in order to be able to travel. So they wanted to tackle this problem and create a scheme that would solve it before it was even a problem to begin with. Now, ITSO has been widely deployed for quite a while now. The English National Concessionary Travel Scheme launched ITSO cards in 2008, so allowing people who are over the age of 60 or who are disabled to access free or heavily discounted bus and rail public transit services. Additionally, in Scotland, there's a similar scheme available, again, for disabled people and folk over 60. And at the moment, there is a discount for people between the ages of 16 and 18, although next year, bus travel will be made free for everyone under the age of 19 through the same scheme. Additionally, the Department for Transport have mandated that ITSO be used for any new smart card schemes launched in the United Kingdom. And they've made this a condition as part of the rail franchise agreements that are used for the different train operating companies when they are awarded contracts to operate on particular routes. One example of where ITSO can come into play is with the Abertay University student cards. So this is what my student card looked like when I was still a student here. And one thing that I was really interested by is that there's this neat ITSO logo on the back of the card. And when I was first given this card shortly after moving to Scotland, I was immediately curious as to what this implied, because it meant that my student card could potentially do a lot more than just let me print and get books out of the library. As it turns out, I was right. I can do the aforementioned two functions with the university. There are a bunch of different features that the council in Dundee facilitate through the use of the smart card as well. And I can also sideload various different travel products onto the smart card as well. So I can put bus tickets on it. I can put bus tickets that are valid across all of Dundee and East Fife on it. And I could also load on Glasgow Subway pay-as-you-go credit. And this is something that I was really excited about when I first moved to the UK 4 years ago. Just the fact that I could take my student card issued in Dundee, go to Glasgow, put it in a ticket machine, immediately put money on, and just be ready to travel. I wouldn't need any more cards. I could just use this one card, and essentially, I'd hopefully be able to travel across the whole of the UK. Now, at the end of December 2016, all of the ITSO cards based on MIFARE Classic, which is what my student card was based on, expired. And this meant that I was no longer able to travel using my student card, and I was kind of stuck in that I had about 10 quid left on the card, which I no longer had access to. So I went to SPT, who managed the subway in Glasgow, and they weren't super enthused that I had been using my student card to access the subway. They offered to transfer the balance over to a ScotRail card, which was one of their supported cards, but sort of really discouraged me from trying to use any other ITSO card that they hadn't officially agreed to have be supported, right? which sort of seems contrary to the whole purpose of the specification, right? It's supposed to be interoperable. You should be able to just mix and match cards. But, okay, this was at the beginning of 2017, so, it's been a few years since then. Hopefully things have changed. And indeed, back in November, Transport Scotland launched a campaign to motivate people to consider smart travel instead of using regular paper tickets and the like. And they make this point that you can pick smart card, any smart card, right? So hopefully this means that the situation has gotten better in Scotland, right? So, okay, fine. I went over to SBT, and who's the organization that I originally sort of had issues with, and their frequently asked questions says, okay, well, you can use your subway smart card on a variety of different bus operators, but you should check with each of them to see if they'll accept it. So I did. And I went and checked that with all of the operators that are issuing smart cards in Scotland. And as it turns out, it's a mess. There are a lot of tickets that are issued by different companies that they will only load on their own smart cards. Sometimes you can cross-load tickets onto different companies' smart cards. In some cases, for example, if you have if you have one of the Abertay student cards and you want to put Explore Dundee bus tickets onto it, you have to take your card to their office and they have to activate it with their system, so you can't just go on a bus and use it. There are some circumstances where different issuers have different types of cards, so ScotRail offer both anonymous cards and they offer cards that have your photo on them, and depending on that, you're restricted on what kinds of tickets you can use. But this is very far from having any sort of integrated transport, right? The fact that you even have a table that looks like this is just way beyond the scope of what your sort of average public transit user would care to try and figure out. So what this means is that in practice, I now just have a drawer for UK smart cards, right? Now, admittedly, I probably have a lot more smart cards than the average person does, like, given that this was something that I was explicitly researching. But even if you're just someone that's going within Scotland, you're still probably going to need multiple smart cards to use across different cities. But, okay, let's take a step back. How is this supposed to work to begin with, right? We can see that sort of 20 years on after the specification has been developed, things haven't really gone to plan. And as an ethical hacking student, I was really curious to understand, is this actually secure? What is the security mechanism that's built into the specification that allows arbitrary public transit operators to write to different cards and still have confidence that their products aren't going to be tampered with? So, as it turns out, given that ITSO was commissioned by the Department for Transport, you can actually go and freely download the core ITSO specification from their website. You can just find the PDFs online. You don't even have to give them your email address or anything like that. It's just a one-click download. There are 12 parts to the ITSO specification. Of course, they start numbering them at 0. And these cover all sorts of things ranging from how to speak with different smart cards, how to encode data on smart cards, what kinds of products are supported across the scheme, how the back office system should work, how they should communicate with each other. But it's quite broad in the scope that it covers in terms of how to set up this unified environment. And the core principle behind ITSO is that you should be able to have different products existing on the same smart card without prescribing a particular underlying technology. And I think my student card is a really good example of this, where the ITSO specification is flexible enough where the university were able to continue using smart cards for student cards, but just being able to add on this additional transit functionality. And this is really neat because it means that the underlying NFC chipsets that are used by different issuers and even within different generations of smart cards within the same issuer do vary quite a bit. So, for instance, SPT in Glasgow for the Glasgow subway issue both MIFARE Ultralight as well as a sort of ITSO proprietary smart card scheme. But in addition to that, there are a ton of different Desfire cards being used out in the wild as well. And the way that the specification manages to accomplish this is by defining a 3-layer model that separates how products are defined on the card, the shell on the card, which is essentially the equivalent of having a folder on your computer that stores everything on the card. And then you have the actual card layer. So that's the actual underlying NFC chipset involved. And this has been designed so that from the bottommost layer, the product layer, things can be kept fairly generic. Products aren't formatted differently for different chipsets. And then at the shell layer, that's where sort of the compatibility measures come in to normalize things between different chipsets. So within an ITSO smart card, everything is encoded inside of a data group. And what this does is you have a header at the top, which is your label. You have the data set, which is all the actual information that you want to have inside of that packet. And then you have an instance identifier, which is a unique identifier for that data group on the card. And you have a seal, which is ITSO's mechanism for preventing tampering. And I'll get back to that in a little bit later. Data groups all come together to form a directory within the card shell. So essentially, the way that this works is that the data groups are all present on different parts of the smart card. And your directory contains the labels for each of these, which tell a device that's reading your smart card where to find these products on the smart card. And then combining the information from the directory, you can go and look up the various smart products and get an idea of what's on the card. Additionally, ITSO has this log format, which allows for things like journey histories or for transaction histories on pay-as-you-go wallets. So it's a sort of similar concept in that you have various log entries, which are defined as orphan ITSO product entities, and that they're not directly added to the card directory, but instead they're referenced by a product's log, and then you can go from the product and look up each of the orphan products to determine what's happened with that. So as I said, these would be things like when you top up your card, that would be a log entry. When you tap in at a station, that would be a log entry as well. And because ITSO has to be compatible with all these different chipsets, they very quickly realized that they could not simply rely on the chipset level security. So all NFC cards provide at least some basic mechanism for access control. So be it having to present a key in order to read or write information to the card, all the way through to doing actual cryptographic operations on the card in order to prove authenticity. But because this varies quite a bit, ITSO decided to implement their own cryptographic signature mechanism for all of the information that's stored on the card so that they wouldn't have to rely on that. The problem is that the signatures that are stored on the card cannot be verified without access to an ITSO Secure Application Module, so also known as the ISAM. So the ISAM is essentially just another smart card that's located inside every single ticket vending machine, every ticket barrier, and ideally the handheld readers used by train conductors to validate whether the tickets on your smart card are valid or not. The problem with the ISAM, though, is it's something that within the ITSO specification holds a lot of power. This is the same module that's used to generate these signatures as well as verify them. Now, the ITSO specification does provide mechanisms for restricting the impact that a stolen ISAM would have. So, for instance, an ISAM can only emit a certain number of season tickets before it has to be centrally reset. But despite this, there's still great incentive for public transit operators to have as few of these as possible in the wild, just because of how risky it is if one of these are stolen. So with that in mind, there's this extension to the specification called Remote Point of Service Terminals. And the idea is that instead of needing physical access to the ISAM at the point of validation, you put your ISAM inside of a data center somewhere, and then you connect to it over the internet, and you ask it to perform the validation for you, and then you just write that over to the card. A more practical example of where this is used and where you might have actually seen this as a consumer is the concept of remote ticket download. So a lot of public transit companies that use smart cards have started allowing passengers to load tickets onto their smart cards without having to go to a station first. by allowing tickets to be loaded through smartphone apps. So this is an example of the ScotRail app. So I tap my smart card to the card. It says there are no updates currently available for the card, and then just shows me information about what's on the card. But if I had purchased a ticket beforehand, this would go through and actually load that onto the smart card. And this is secured because what's happening is that your phone is just acting as a vessel for the remote ISAM to speak with the smart card with. So your phone isn't actually very involved in the process. Most of the heavy lifting is happening on the server away in a data center somewhere. So unfortunately, the ISAM operation is literally the only part of the ITSO specification that's covered by NDA. And given that the whole reason for a lot of my research is that a lot of this stuff isn't public to begin with, or at least the impacts of it aren't public, I wasn't interested in signing an NDA, and still to this day have not signed an NDA with ITSO. So with this in mind, I have no idea how the ISAM works. Very few people do. Even if you're willing to sign an NDA, you sort of have to have a justification for needing that information. But despite that, there are still a lot of other sections in the specification that we do have access to. And while we don't have access to the detailed operation of the actual ISAM, we do have access to information about how all of the surrounding services around the ISAM speak with it, what kind of data they send to it, what kind of data they expect back. So one of the core principles within ITSO is that they need various different public transit operators to be able to read and write from smart cards that were not issued by them. So the way that the specification tries to handle this while still keeping write access secured is by using a key derivation algorithm to generate keys that are unique for each smart card based on a secret algorithm that's stored on the ISAM. So this means that as long as you as a public transit operator have access to an ISAM, you can then get write access to all the sectors on a card by deriving the keys for it. But the problem is that you need information to begin with in order to derive these keys. In particular, the ITSO specification requires that you have access to format version code, the key strategy code, and the key set version code, all of which are stored on the card itself. So this creates a kind of catch-22 where in order to derive the encryption keys for the card so that you can communicate with the card and read and write information from the card, you need to have already read information from the card to know that initial information, right? So the ITSO specification doesn't try to do anything clever with this. They just outright say, okay, that's fine. And they compromise on giving everyone read access to all of the information located on ITSO smart cards. So this means that you can read out all of the information on a given smart card using a key that is generic to all the smart cards that are based on that particular chipset type. And these keys are either published on the ITSO website or are fairly easy to determine on your own. As a hobbyist, that's brilliant because it means that it's really easy for me to go in and understand what data is on my card. So despite ITSO's relatively open nature, when I began this project, and still to the best of my knowledge, there are no open source implementations of any tooling to interact with a smart card. I mean, sure, there are apps on the Play Store that let you read information off your smart card, but those are all closed source, so as a hobbyist, that's not really interesting to me. So I went ahead and wrote one. So using the publicly available documentation, I wrote Python tooling for the card data. That's available on GitHub. The code is terrible. Don't look at it too closely yet. It was literally written for a uni project, so there are no unit tests. But it's licensed under the GPL, so everyone is free to use it as long as you... but it's GPL to prevent sort of commercial entities from just taking it and making changes to it and keeping those closed source. So PyTravel card provides an extremely basic command line interface. So in this case, it's located in an NFC reader on my computer, and then it's just going through and dumping some basic information about my smart card. But that's just sort of a high level understanding to get an idea of whether this is working. What's more interesting with PyTravelCard is the underlying API that's provided for hobbyist developers to build their own tooling to interact with smart cards. So this is a Python script which goes through and at the very top I'm opening an NFC session and grabbing the card data. After that, I'm going through all the products found on the card, and I'm looking for a stored travel rights product. So that's what's used to store pay-as-you-go balances on a smart card. Then I'm looking to see if that product belongs to the Glasgow subway, and then if it does, I'll go through and print out information about that. So there's just all sorts of information that PyTravelCard tries to return about information that's located on a smart card. So in addition to giving you its own interpretation about what information is on the card, you still get access to the raw byte streams for each of the individual data groups on the card. So as a researcher, it makes it a lot easier to understand the relationship between what are the bytes on the card and what those bytes actually mean. So now I'm going to take a moment to do a live demo. Okay, so at the moment, I just have a smart card reader attached to my computer. Unfortunately, it's on the left-hand side, sort of because of the HDMI positioning, so it's a bit hard to see as an audience member. But here I don't have any smart cards attached to it. Now I'm going to take my trusty ScotRail smart card, put it on top of the reader, and I get information about my last two taps on the Glasgow subway. So that's me tapping in at a station and tapping out at a station, and the total transaction cost was £4.15. Okay. So once I had that tooling, I was really curious to start thinking about, okay, what can I start doing with these smart cards, right? So as I mentioned, my student card was originally issued using the MIFARE Classic chipset, which has plenty of very well-known and very public vulnerabilities for it, which essentially allow you to take control of the entire card by being able to derive all of the encryption keys that it uses. So using these vulnerabilities, I was able to clone my student card onto just a blank NFC card. So over on the left, it's saying unknown MIFARE, possibly clone. But on the right, this is a publicly available ITSO smart card checker, and it's still happy that my card looks fine, it seems valid. But sort of as I had mentioned, this card did expire at the end of 2016, which kind of sucks. Because it'd be neat if I could keep using that card, right? Now, the problem is that tampered cards cannot be checked offline without physical access to an ISAM. So I went ahead and changed the expiry date, I changed the card number, but it still thinks that the card is valid. Because the app just doesn't know any better, and it can't know any better. Because of how the specification is written, there's just no way for it to be able to determine whether the card has actually been tampered with. Unfortunately, I will not be demoing this because I would really rather not get deported. So please don't ask me how I did that. The information on how to do it is fairly publicly available anyway. But this is really a problem when train conductors for a certain local train operating company often use their corporate phones, which don't have access to an ISAM, for ticket validation. Additionally, when you're traveling on some of the routes operated by this train company, there's often a lack of mobile data service available. So it's not really feasible for them to make use of this remote ISAM functionality anyway, because there's not good enough mobile data infrastructure available for them to be going online to validate each of the tickets. And this is just a really good example of where requiring specialized equipment in order to do ticket validation just leads to ticket validation either not happening, where I might wave my smart card at an instructor and they'll just go, "Cheers, pal," or they'll half validate it in that they'll see what information is on the card, but not actually be able to tell if that's genuine or not. And this is part of the problem with losing an ISAM being an incredibly risky proposition for a public transit operator. The ITSO specification says that if you have an ISAM in some sort of device that's going to be moving around, it has to be really heavily secured. You can't be able to extract it from the device without needing a tool to open it up. And so, as I was saying, like, operators are directly incentivized to deploy as few ISAMs as they can get away with, while it's still a crucial component to validating the integrity of any smart ticket issued on the ITSO scheme. And further than this, I sort of think that ITSO's directionless flexibility really gives public transit operators an excuse to be lazy with their smart card deployments. It is really easy to just lift and shift your existing paper ticket products onto smart ticketing products without considering all of the other possibilities that are facilitated by using a smart card to begin with. And a really good example of this is this document published by the Rail Development Group, who at the time was known as the Association of Train Operating Companies, where they've essentially gone through every single paper ticket that exists within National Rail, and they've tried to map it to the ITSO specification. And in some cases, they just haven't managed. A few years ago, ScotRail tried doing advanced single tickets, that is, tickets which are restricted to one particular train at a particular day and time, on ITSO smart cards, and they just couldn't manage to actually encode what time the ticket was valid for. So you could buy a ticket for a train which was way cheaper, and then just travel on any other train because the conductor has no idea which train your ticket is actually valid for. So, I mean, the sort of question is, like, if not ITSO, then what? I think in an ideal world, we'd discontinue these weird DRM-encumbered M-tickets that some train operating companies provide, and switch to just unrestricted e-tickets, which other train operating companies provide, which lets you just print them out on ticket stock, on regular computer paper, or just be displayed on a mobile phone without downloading an app. And it'd be great to see more train operating companies use these e-tickets for advanced single. So ScotRail, for example, have still been dragging their feet on supporting e-tickets at all, because they're still trying really hard to push for their smart card scheme. Additionally, it would be really great to see fixed origin destination stored tickets on ITSO, so things like singles, returns, or carnets just be discontinued in favor of simplified zone-based ticketing. But even better than that would be something like an account-based pay-as-you-go scheme, because the whole thing with smart cards is the computer knows where you've gone. You're tapping in, you're tapping out. And the computer is a lot better than you are at figuring out which ticket is the best value for any given travel that you're doing. There's no reason why I, as a consumer, at the beginning of the day, should have to decide whether a single, a return, or even a week ticket is going to be the best value for my travel, when the computer should just be able to figure that out for me. And I think a really good example of this is some of the work that Transport for London have done in this industry. And when Transport for London launched, started beginning their investigations into smart ticketing technology, they were forced to innovate in that there was nothing else available at the time, and the very early NFC technologies that were available were extremely limited in terms of how much storage space they had available. So it would have been completely impractical for Transport for London to ask people to preload a single ticket journey on their smart cards before travel every time. So to sort of go through these, in 2003, Oyster launched just for season tickets. As I said, because of this restriction with space on the card, season tickets are way simpler. You're loading one on for months at a time. The next year, they introduced pay-as-you-go journeys for both buses and rail. The year after that, they introduced automatic daily price capping. So this meant that as a passenger on TfL services, you could just ride all day, and if it turns out that it would have been cheaper for you to buy a day ticket, the system just goes, okay, I'm going to pretend you bought a day ticket, and it caps your usage at the price of a day ticket. But likewise, if your traveling doesn't meet the price of a day ticket, then that's fine. You're not wasting any money because you're still only going to spend up to that point. 2010, they rolled out Oyster Pay-As-You-Go to all national rail services within the capital. In 2012, they were the first public transit operator in the world to accept contactless bank payment cards for use on their services. And today, they now process 1 in 10 of all UK contactless transactions, and they're one of the largest contactless merchants in Europe. In 2016, they then licensed that technology to Cubic Transportation Systems, who are rolling it out quite successfully in various different cities across the world. So Sydney recently launched their contactless travel scheme based on TfL's technology a few months ago, and New York are currently in early trials for their contactless-based scheme as well. And I think the really interesting thing is Oyster kicked off in 1991. Now, if we think back to the first slide, that's 7 years before ITSO even started. And yet, throughout all of Oyster's history, Oyster has never been, and still is not, an ITSO smart card. It has always been its own smart card that uses its own proprietary back-end system. And I think the sort of crux of this problem is computers allow us to just scale problems that we'd otherwise make better solutions for, because it's way easier to just throw brute force at the problem than it is to actually sit down, think about it, and try and come up with better solutions. And with that in mind, I think it's time that we stop asking, how do we migrate paper tickets to smart cards? And we start asking, how can we leverage the unique benefits that smart ticketing provides? Before I close off, there are a handful of people on the screen that I want to thank throughout this research. I spent about a year of my life conducting this research, and I definitely wouldn't have been able to manage it without everyone listed here. That in mind, thank you for listening. So we have a lot of time for questions. So if anyone has anything they'd like to ask, I'd be happy to answer as best as I can. Sure, Sam in the back.
Do you think, with the current state of like the rail industry being split into many different private companies, I mean, not to get too political, but like, how feasible do you think it would be to kind of have a standard that all those companies could be encouraged to use? And do you think that would help the development and standardization?
Sure. So for those that didn't hear, the question was, given the state of the fractured privatization of Britain's railways, what would the feasibility of a unified standard to combine all of these be? And I think this is why Transport for London is also a really interesting example, because they're the only place in the UK where they've actually managed to do this, but it's also because Transport for London are the only organization that's actually been willing to step up and handle fare settling on behalf of all of the different transport companies. The entire point of ITSO is that it's decentralized, so nobody has to handle fare settling for different transit providers. But this also means that if I have pay-as-you-go balance on my card for Glasgow Subway, I can't then go and use that on like the Tyne and Wear Metro. They're just not compatible. They don't touch each other. And I think unless the UK government steps in and starts facilitating that fare settling, we're just not going to see a unified smart card scheme, the likes of OV Chipcart in the Netherlands, where there's just one smart card that works across all public transit in the country using one pay-as-you-go balance. And so in practice, I think what's probably going to happen is the UK government's unlikely to step in that role, and instead we're just going to see more of a shift toward contactless payments where the banks are acting as fare settlers instead. Ooh. Anything else? All right, brilliant. Well, you have an extra 20 minutes before lunch, but I really appreciate all of you giving me your time today. Thank you.